Okay, so we're looking at number 1 here. We have a rational function, x squared minus 2x minus 3, all over x minus 3. And if we look at the graph of it, it's a straight line. So why is that? All right, so if we factor it, we'll be able to see what happened. I've got x minus 3 times x plus 1. Oh, yeah. All over x minus 3. Right? It's hard to see on my thing here, but that's what I've got. And so, and that's y equals that. All right, so notice that the x minus 3's are going to cross out. That would be my whole, right? When x is 3, that is going to be a whole. All right, so what I end up with then is y equals x plus 1. All right, so when x is 3, y would be 4, and that is going to be my whole. All right, so that would be a discontinuity. There's no vertical asymptote, because if you look at the graph there, all right, when it divided out, I get a straight line. And you can tell by the exponent, notice the exponent here is greater, right? 2 is greater than 1. All right, so that means there's going to be no asymptote. All right, oh, no horizontal asymptote. All right, and notice you get your straight line. So there's no horizontal asymptote. I get a line there, a slant asymptote, and my vertical discontinuities would be whole. You can see there's no vertical asymptote. And then now if I'm looking for the x-intercept, well, that is where y is 0, right? So when y is 0, x is negative 1. All right? And you can see that by looking at the equation as well. All right, when so for horizontal asymptote, we're going to write none. Vertical asymptote, none. I have my whole here when x is 3. Right, that would be the whole. And then I've got my x-intercept is where you have y is equal to 0. And so to make y be 0, x is going to be negative 1. All right, and my y-intercept is going to be when x equals 0. All right, and when x is 0, y is 1. So when x is 0, y is 1. All right. My domain, well, it goes forever from negative infinity, but when I get to the whole, it is going to be disconnected. And so then I have, but I pick right up at 3 and go on to positive infinity. Okay, and then my range, you can see it goes forever, negative infinity. Actually, it's going to stop too when it gets to that whole, right? So that would be negative infinity to 4. And then I'll pick up at 4 and go to positive infinity. All right, so there is that one. All right, and you can see that on the graph. There is my x. There's my x-intercept. Here's my y-intercept. And when x is 3, 1, 2, 3. Oops. Oh, here's when x is 3. When x is 3, notice y is 4. And it's undefined right there. Okay? Okay, very good. So let's look at the next one. I've got x squared on top, and x to the third in my denominator. So my denominator is bigger. So it seems like I will have a horizontal asymptote. I'll put that into my Desmos. Okay, so we put that into Desmos, and you can see the function, and you can see that when you look at as x goes to negative infinity, right, the end behavior here, and as I go to positive infinity, it seems to be approaching this right there. It seems to be approaching y equals 1, and that makes sense because my exponents are the same, actually. They're both 2. Right? So if they're the same, everything is going to divide out, and basically I'm looking at the coefficients, which would be 1. So y equals 1 should be the horizontal asymptote. So I'll go y equals 1, and there it is. You can see that is what the function is approaching as you go to negative infinity and positive infinity. All right, so the horizontal asymptote is y equals 1. Is there a hole? It's hard to say. It doesn't look like a hole. We'll factor it and see. Okay, so factoring this guy, I've got, that would be x plus 2 times x minus 2 all over x plus 1 times x plus 3. Right? So there's no hole, right? There's no hole there. My vertical asymptote, we said, is y, or excuse me, horizontal asymptote is going to be y equals 1, all right? Because there's my coefficients. These were both, the exponents are both 2. And so now the discontinuities, all right, I can see looking at the graph that I had some vertical asymptotes. All right, you can see right here, right, where it's going to positive and negative infinity, right? And so where are those? Well, those, if you look at the factors, all right, that would be when x equals -1, right? -1 make that 0, and x equals -3. That would make that 0. All right, so those are my vertical asymptotes. And there is no hole. All right, now the x-intercept would be when y is equal to 0. So what values are going to make the numerator 0? Right, y is going to equal 0 if it's 0 over x, right? That equals 0. And so to make my numerator 0, that would be if x equals -2. I'll write that as a point. So one x-intercept is going to be when x is -2, that would make it 0, and also when x is +2. All right, so those are my two x-intercepts. And again, if I look at my Desmos graph, you can see where it crosses. Right, these are my x-intercepts at -2 and +2. Okay, those are my x-intercepts. And if I'm looking for my y-intercept, that's going to be down here. All right, my y-intercept is going to be when x equals 0. All right, so looking over here, when x is 0, well, x squared would be 0, and that's 0, and that's 0. So when x is 0, I've got -4 over 3, -1 1/3, and you can kind of see that's where that is. Okay, x would be 0, and then that would be -4/3. Okay, so I can put that down here. X is 0, and that's -4/3 for the y-intercept. And then for my domain, all I have to worry about these the discontinuities, all right, so the vertical asymptotes, so I'm going to go from negative infinity, and then when I get to -1, there's a problem. And then I pick up from -1 to -3. Oh, excuse me, that would be -3. And then -3 to -1, and then -1 to positive infinity. Okay, you can see those different things right here. All right, so here's one domain, the other domain, and the other domain. Okay, it's like 3 different intervals there. And then looking at the range, it goes forever, right? Looking at here, forever to the negative infinity to positive infinity. There's no, oh wait, no, there is none because I got my horizontal asymptote, but then this one goes through it, right? The middle one does. So I've got negative infinity, positive infinity for my range. Negative infinity to positive infinity. All right, that is number 2.